Good everyone, my name is Graphics. Looking at your screen, you will see a question that is displayed there, and we are told to use mesh analysis to find the current that is flowing through the 9 ohm resistor, right? Now if you look closely, this circuit comprises of 4 elements. Two of the elements which are passive element, and the other two is what? Active element. Now, if you look at the active element are the element that provide energy into the circuit, and we have the 3-volt source and the 2 ampere current source, right? And the passive here are the one that consume and distribute, and these are the resistors. And the resistance of this resistor are 6 ohm and 9 ohm respectively. Now we want to use mesh analysis to find the current that is in this circuit, especially the one flowing through the 9 ohm resistor. Now let's assume that this is mesh 1, we'll call it I1. This is mesh 2, we'll call it I2. Or we can call it loop 1 or loop 2, whatever one you want to choose. Now, if the current that will be flowing on this part here will be I2. So let's follow the direction of the current. 2A is flowing in this way, so I2 is going towards this direction. Are we good? Just like you can see. Now when I2 get to this point here, let's call it point B, which is a node, it splits, right? Meaning that the I1 will be going towards this direction also, and the I3 will be coming down this way. It splits into two, one going down and going towards the left. Now, this is what we have here. Now, let's now name them. This is point A, this is already point B, this is C, D, E, F. Now, what is the I3? Let's look what I3 is by applying the Kirchhoff current law, which is that the sum of current entering the node is equal to the one leaving the node, right? So let's say the current entering the node. The only current entering this node here is I2, right? Equals to the current leaving. The current leaving this node here is I1 and I3 since they are moving away. You can see away from the node. So we have I1 plus I3. So the sum of the current entering is equals to the sum of the current leaving. Now, if I make I3 the source of the formula, my I3 will be equals to what? I2 minus I1. Are we together? Now, what is my I2? We already know my I2 is this current source here, which is what? 2 ampere. So we say I3 is equal to 2 minus 1. So that is my I3. So what I'll be putting here to represent my I3 is what? 2 minus 1. So let's search forward. Now we want to consider mesh ABEFA, right? Mesh ABEFA. And this is what we have here. Is that taken? I brought it out for better understanding. Now, if you look at it, I'm taking a clockwise movement. I'm moving in a clockwise direction this way. So if I'm starting from part FA, like FA here, if the current moves from a lower potential to a higher potential, right? We say that the voltage here is positive. Are we together? Now, since I am going towards the right, and the direction of the current I1 is coming towards the left, meaning that what? The voltage there will be what? Positive. So it will be 6 times I1, and that will be what? Plus 6I1. Is that okay now? Now, I'm now going through the part of I3 now. You see I3 is coming down, and I'm going towards the same direction of my I3, the way I'm rotating. You can see that clockwise. So that is why it will be negative. So if you are moving in the same direction as the direction of the current, you will take your voltage to be what? Negative. So our voltage is the current times the resistance, right? So I'll be having minus 9 times I3 equals to what? 0. Now, if I rewrite this, I'll be having 3 plus 6I1 minus 9 into bracket. I3 is given as what? 2 minus what? 2 minus I1, right? Equals to what? 0. Now from here, if I write this again, I'll be having 3 plus 6I1 minus 9 times 2 is 18, minus 9 times minus I1 will give you plus 9I1 equals to what? 0, right? Now if I collect like terms, my 6I1 plus 9I1 will give you 15I1, right? Then 3 minus 18 will give us what? Minus 15 equals to 0. So 15I1 here, if I take minus 15 to the other side, will be equals to what? 15. Now, if I divide both sides by 15, I'll be having I1 is equals to what? 15 all over 15, and that will be giving us what? 1 ampere. So my I1 here is 1 ampere, right? Now recall, we know that I3 is equals to what? 2 minus I1 from our equation up here. Let's say that is equation 1. So if I input my I1 there, my I3 will be given as what? 2 minus 1. So meaning that my I3 is equals to what? 1 ampere. So this means that the current that is flowing through my 9 ohm resistor is what? 1 ampere. Just like what I got while I was using superposition theorem to solve this same problem. And if you want to come across, you want to understand how to use superposition theorem to solve this problem, click on this link at the top right corner of the screen. Here you see this link here. It will take you to a place where you can learn on how to use superposition theorem to solve this same question, right? And you get the same answer. Is that okay now? So we have concluded that the current flowing through the 9 ohm resistor is what? Is 1, meaning that my I3 is 1 and also my I1 is 1, meaning that what? These 2 ampere, when you get to node B, it splits equally to the 2 resistors here. Is that okay? So most time they might tell you to find the voltage drop across the 9 ohm resistor. I will know voltage drop is using the Ohm's law is equals to what? IR. So the I here is the I3 flowing and the arrow here is the 9 ohm here. So when you multiply both of them, you'll be having 9 volts. So the voltage drop across this resistor is 9 volts. Similarly, the voltage drop across the 6 ohm resistor is the same, 6 volts. Are we together now? So we have successfully gotten my I1 to be 1, my I3 to be 1, and the I2 is given as what? As 2. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.